In this video, we'll see how to solve logarithmic equations. There are two ways to do that. The first one is if your equation can be expressed in the form of a single log base b of m is equal to c, then the technique that we use is use definition of a logarithm to rewrite the equation in exponential form and then solve. So the first equation, we have log base 2 of x minus 4 is equal to 3. That's in the right form. So rewrite it as a power. 2 to the power of 3 is equal to x minus 4. Now it turns into a nice easy linear equation. 2 to the third is 8, so I get x minus 4 is equal to 8. Add 4 to both sides, we end up with x is equal to 12. Then on these, since the domain of logarithmic functions has to be the log of a positive number, check and make sure it works. X equals 12, 12 minus 4 is 8. We could take the log base 2 of 8 is equal to 3. The next equation, 4 times the natural log of 3x equals 8, isn't in the right form yet. We have to have a logarithm by itself. So the first step is to divide both sides by 4. Then we get the natural log of 3x is equal to 8 divided by 4, which is 2. Now rewrite it as a power. Natural log has base e, so we end up with e squared is equal to 3x. Divide both sides by 3. X is equal to e squared over 3. So this would be your exact answer, and if you needed it to a couple of decimal places, then you could use the calculator. Next example, using this technique, rewriting a side to a single logarithm. We have log x plus log x minus 3 is equal to 1. These two logarithms have the same base. That means that we can combine them using the product property. So this is going to be the log of x times x minus 3 is equal to 1. That gives us the log x times x is x squared minus 3x. Now from here, we can go ahead and rewrite this logarithm as an exponent. That's log base 10. So rewriting it as an exponential form is x squared minus 3x is equal to 10 to the power of 1, which is 10. Okay, so now we have a quadratic. So we take our x squared minus 3x, take the 10 to the other side, minus 10 is equal to 0. Factor if you can. If not, use quadratic formula. We have x, two numbers that when we multiply them we get negative 10, and add we get negative 3, would be minus 5 plus 2. So our two solutions, possible solutions, are x equals 5 and x equals negative 2. Then check back in the original problem. Does x equals 5 work? Yes, log of 5 plus log of 5 minus 3 is 2. We have positive values, so x equals 5 works. X equals negative 2 doesn't work because we have log negative 2, and we can't have a logarithm of a negative number. So x equals 5 is our solution. All right, so that's the first technique. The second technique is when you have logarithms written on both sides. So if your equation can be expressed in the form log base b of m equals log base b of n, then we can have the single logarithm and set m equal to n. So notice the next example, solve natural log of x minus 3 equals the natural log of 7x minus 23 minus the natural log of x plus 1. The left-hand side is written as a single logarithm. See if you can write the right-hand side as a single logarithm with the same base. We can use the quotient property, natural log. This would become 7x minus 23 over x plus 1, because we're subtracting. Once you have the same logarithm on both sides, then you can set x minus 3 equal to 7x minus 23 over x plus 1. Then you can set what you're taking the logarithm of equal to each other. So now let's Now that equation is no longer a logarithmic equation, now it's algebra. So what do? Multiply both sides by x plus 1, cross multiply. We get x minus 3 times x plus 1 is equal to 7x minus 23. Multiply out our expression, we get x squared minus 3x plus x minus 3 is equal to 7x minus 23. It's a quadratic, so get everything on one side. We have negative 3x plus x is negative 2x, and then we're going to subtract 7, so we end up with minus 9x. We have negative 3, we're going to add 23, we have plus 20 is equal to 0. Solve the quadratic. This one looks like it factors, but if it didn't, you'd use the quadratic formula. We need two numbers. 4 times 5 gives us 20. Negative 4 plus negative 5 gives us 9. So our two solutions are x equals 4 and x equals 5. Then you check, does x equals 4 work? The natural log of 4 minus 1 equals natural log of 7 times 4 minus 23 minus the natural log of 4 plus 1. 4 times 7 is 28. Yes, we'll have a positive in all those spaces, so x equals 4 works. And then 5 is larger and positive. That's also going to be a solution. So we get two solutions to that particular problem.